All right, welcome. Today, we are diving into some of the most valuable substances in the entire world. And when I say valuable, I mean prices that are just absolutely mind-blowing. So, let's get right into it.
So, let me ask you something. What do you think is the most valuable substance known to us? If your mind immediately went to gold or maybe platinum or even something exotic like saffron, well, you're not even in the ballpark. The real answers, they're found deep inside our planet, in super advanced labs, and even way out in the final frontier of space.
Okay, so for our first stop, we're going to start our journey deep within the Earth's crust. We're on the hunt for gemstones that are so incredibly rare, they honestly make diamonds look, well, kind of common.
Kicking things off, we have tafinate. Just look at this gorgeous purple gem. It is one of the rarest minerals you can find anywhere on the planet. And here's a cool fact, it was actually discovered after it was already cut and polished. Someone thought it was a different, more common stone. That pretty much never happens in the world of gemology.
So, how much for something this rare? Well, it'll set you back a cool $100,000 per gram. Yeah, you heard that right. And believe me, we are just getting warmed up. This is our starting point.
All right, next up, we've got a pair of stunners. First, there's granditerite, with that beautiful bluish-green color. And then there's muscovite, which is actually a close cousin to the taphite we just saw. Both of these are just exceptionally rare. They only form under super specific geological conditions, and you can only find them in a tiny handful of places around the globe. Price-wise, granditerite is going to run you about $105,000 a gram. But muscovite, with even fewer gem-quality pieces ever discovered, that price jumps way up to $175,000. I mean, we are talking about gems that most jewelers will go their entire careers without ever seeing in person.
Okay, this next one has a great story. This is Painite. Now for decades, and I mean decades, there were only 2 known crystals of this reddish-brown mineral in the entire world. That's it, just 2. It even held the Guinness World Record for the rarest gemstone on Earth.
Now it's true. More has been found since then, but that legendary status, being the absolute pinnacle of rarity for so long, has kept its price sky high. We're talking an incredible $300,000 a gram.
All right, take a deep breath because we're about to enter a whole new league. We are talking about diamonds now, but not the kind you see in a typical jewelry store. No way. These are the absolute rarest of the rare, where just a tiny hint of color changes, well, it changes everything. So on the left, you've got the stunning blue diamond. That incredible color comes from tiny traces of boron that got trapped inside as it formed. And on the right, that's the red diamond. This is arguably the rarest of all colored diamonds. And what's wild is its color doesn't come from an impurity, but from a super rare hiccup in its crystal structure. And the prices? Whoa, they are just staggering. A blue diamond can go for around $15 million per gram, but the red diamond? That commands an absolutely mind-blowing $25 million per gram. At this level, you're not just talking about jewelry anymore. These are serious, major investment assets. Okay, we're going to switch gears completely now. We're leaving the natural world of gems and minerals behind, and we're stepping into the lab. We're entering the world of nuclear physics and nanotechnology. This is a place where rare isn't about what you can dig out of the ground. It's about what we can create with incredible human ingenuity and a whole lot of energy. Just look at this iridescent material. This is curium-244. You're not going to find this in a mine anywhere on Earth. Nope. This stuff is born in the blazing heart of nuclear reactors. It clocks in at around $185,000 a gram, and it has to be painstakingly extracted from spent nuclear fuel. So, you might be asking, why go to all that trouble? Well, this is the really cool part. It's used as a power source in something called an RTG. Think of it as a nuclear battery. These are what power our spacecraft on those really long missions into deep space, way too far from the sun for solar panels to work.
All right, next on our lab-created list, meet Californium-252. And yeah, as you can probably guess from the name and that glow, it is highly radioactive and, of course, incredibly valuable.
So how do you make this stuff? It's basically modern-day nuclear alchemy. You actually start with curium, the stuff we just saw, and you put it in a special nuclear reactor and just bombard it with neutrons for a very long time. Eventually, it transmutes into californium. The whole process is just fantastically complex and honestly super inefficient.
And the result of all that work is a price tag of, get this, $27 million a gram. But this is a perfect example of cost being tied to what something can do. Californium is an amazing source of neutrons, which means it's used for some really critical things: kickstarting nuclear reactors, fighting aggressive forms of cancer, and even helping us find oil and water deep underground.
Okay, get ready for something that sounds like it's straight out of science fiction. This is an endohedral fullerene. Now, this isn't an element, it's a molecule. And here's the best way to picture it. Imagine a teeny tiny hollow soccer ball made of carbon atoms, and right in the middle, you have a single nitrogen atom trapped inside. A molecule in a cage.
The level of precision you need to build this is it's mind-boggling. And that's why the price is what it is, $160 million per gram. But what do you do with it? Well, its purpose is to create unbelievably precise atomic clocks. We're talking clocks so small and accurate they could fit inside your phone. And that could totally revolutionize things like GPS, self-driving cars, and even the future of quantum computing. All right, for our last few entries, we have to look up. Way, way up. We're going to space, and then we're going to explore the very fabric of the universe itself.
I know what you're thinking. This just looks like a pile of gray dust, right? Well, that pile of dust is actually one of the most precious substances we have here on Earth, because that is moon dust.
So what makes it so expensive? It's not the dust itself, it's what it represents. The value here is a direct measure of human ambition. It's the absolutely astronomical cost of building rockets and flying missions to another world, just to bring a few samples back. And its scientific use? Honestly, it's priceless. It helps us unlock the very secrets of how our solar system was formed.
And here we are. We have finally arrived at number 1, the most valuable substance known to humankind. It's not a mineral. It's not something we can make in a normal lab. It's the literal mirror image of everything we know. This is antimatter.
So here's the deal with antimatter. When it touches regular matter, the stuff that makes up you, me, and everything, they both just annihilate. They vanish in a perfect conversion of mass into pure energy. So the big question is, what would it possibly cost to create and safely contain just a single gram of this stuff? You might want to sit down for this. $62.5 trillion. Let me say that again. $62.5 trillion. That is more than half of the entire world's economic output for a year. The sheer staggering amount of energy it takes to create antimatter, atom by atom in a particle accelerator, makes it without a doubt the most expensive substance we can even imagine.
Right now, we can only make it in absolutely microscopic amounts at giant facilities like CERN, mostly for fundamental physics research. But here's a mind-blowing connection to our everyday lives. A form of antimatter called positrons is already used in medicine. It's the P in PET scans, helping doctors detect diseases like cancer. So as we've seen, value is a really complex idea, isn't it? It's not just one thing. Sometimes value comes from winning the ultimate geological lottery, like finding a red diamond. Sometimes it's born from the mind-bending complexity of nuclear synthesis, like with Californium, or the microscopic precision of nanotech. Other times, value is simply the price of an incredible journey, like bringing back moon dust. And at the very top, value is the pure raw energy cost of creating the most exotic particle in the universe, antimatter.
And all of this leaves us with a really fascinating question to chew on. As our technology gets better and better, which of these substances do you think will become more common, maybe even cheaper? And what new material, something we haven't even discovered or created yet, do you think could one day knock antimatter off the top spot? It's definitely something to think about.